Graphing reciprocal functions can be easy. There are a lot of pitfalls within this. Consider this kind of an introductory way in which to graph reciprocal functions. Now, my setup for graphing is always going to be pretty similar. I'll have a graph, I'll have a table of values, and I'll have a chart or some sort of idea about asymptotes, holes, and my intercepts. If I can find those things, I think my graph is off to a good start. And the equation we're going to work with today, again, kind of an introductory one, although not basic by any means, is going to be the equation you see here in blue. And as you've seen with any teacher showing you this, your first step is to simplify this expression. So I'm going to first factor out a common x from the bottom. And then because I think I can factor this trinomial even more, I'm going to go ahead and do that. My goal is trying to cancel out anything that I can cancel. Plus 2 and an x minus 1. I think we're good there. Yep. What I find is that I don't have a lot that I can cancel. I can cancel out an x, which gives me a hole. When x is 0, well, let's see. When x is 0, I find myself having a 0 here and a 0 here. So I end up with 2 over 0 plus 2 and 0 minus 1. So that's 2 over negative 2. So I have a hole at negative 1, 0, negative 1 is going to be where my hole is. All right, having said that, let's clear off some other stuff here. Just neaten everything up again, right? You can always pause the video and go back and look. Now let's deal with asymptotes. I'll get back to a normal color in purple. Vertical asymptotes are always going to be, well, after we've canceled out the x, whatever remains behind in the denominator becoming zeros. So for this one, if x is negative 2, and for this one, if x is 1, we're going to have an asymptote. So x is negative 2 and x is 1. That's going to be the asymptote there. Let's clean again. Horizontal asymptotes, what we find in this case, and I describe this as being bottom heavy. What I mean by bottom heavy is that the degree of the denominator, x times x would be x squared, and x squared has a degree of 2, is greater than the degree of the numerator. Now, once that x cancels out, I actually have a degree of, well, it's a constant, so that gives me a degree of 0, because there's an x, but it's to the 0 power. So this one has a greater degree on the bottom. I'm going to refer to that as bottom heavy, and anytime I'm bottom heavy, the horizontal asymptote is automatically y equals 0. While we're on horizontal asymptotes, you can't have both of these. If you have one, then you don't have the other. So the fact that I have a y equals 0 means I have no slant asymptote. It should be noted that there are times when you won't have either one, but in this case, you do not have the slant asymptote. And finally, for the x and y intercepts, let's go ahead and clean this up a tiny bit again. What I'm going to do is use my simplified equation. This is getting a little cluttered, so I'm going to rewrite. And what I'm going to find is that if I have an x-intercept, that means that that y is 0. And likewise, if I have a y-intercept, that means that at some point x equals 0. So I'm going to simply use those two facts to try to figure this out. Since this equation, or as it looks right here, an expression, so this equation, if this thing equals 0, right, if the y becomes 0, that means my numerator has to be 0. Now, in this particular case, there's no way to make a 2 into a 0. I'm not going to stress that. I'm simply going to say we can't make 2 into a 0, so I'm going to say there is no x-intercept. As for the y-intercept, that means x equals 0. So everywhere where I see an x, I'm going to put a 0. I'm going to find myself with a 2 over 0 plus 2 is 2. 0 minus 1 is negative 1. 2 over negative 2 is negative 1. So my y-intercept is negative 1. All right, you can go back and rewatch that as needed. But now I'm ready to kind of minimize that work that I've done. I'm going to keep the chart. And now I'm going to turn everything into a graph. And I'm going to get a little aggressive with some of this stuff here. Let's go purple again. And let's start off with the hole. 0, negative 1 is going to have a hole. Vertical asymptotes, x is negative 2 and x is positive 1. I have a dotted line feature here, so x is negative 2 and x is 1. My horizontal asymptote is y equals 0. And we'll Make that on the grid there. There's no slant asymptote. I have no x-intercepts, so nothing to graph there. And I have a y-intercept of y equals -1. Now that kind of conflicts with the fact that it looks like there is a hole there, in which case there is. What I want you to know about this x-intercept and y-intercept is this is really just kind of it's almost like a hint for graphing. It's not that those points do or don't exist. This one, there doesn't. In this one, there's a hole there, so it doesn't actually exist either. Those are simply indicators of helpers to your graph. They simply help you draw a picture. So with that in mind, I don't have much of a picture. So what are we going to do with that? Well, here's what we're going to do. We're going to take, back down in the work, if you remember what we did, we factored, and then we simplified. So I'm going to grab this thing, and I'm going to move it up next to my graph. Okay, let's get this all set up here, make this nice and pretty, and let's use the eraser tool to get rid of those things we've canceled out. So now I have myself a simplified value. Now, what am I going to put in there? What am I going to put inside of my table? Well, it's all about the graph and what I've created so far. So I'm going to use a highlighter tool to kind of show this off. Here's what I don't know. I don't know what happens when x equals 2 or x is 3 or x is 4, and I'm kind of curious about that. Likewise, I don't know what happens when x is -1, when x is -3, when x is -4, when x is -5. So those are really good places to start, and I'm going to go ahead and list those out. I didn't know what happened when x is 2, 3, or 4. I didn't know what happened when it was -1, -3, -4, and -5. And what you're going to find that I'm going to do, and I'll use blue for this since I'm kind of working with blue here, is I'm simply going to put those numbers into this purple simplified equation. So I'm going to start with a 2. So I put a 2 here and a 2 here. I get 2 over 4 times 1. So 2 over 4 is 1/2. All right, clean this up, and I'll do it again. I'm now going to put a 3 in there. Writing on top of it's a little sloppy, so I'm going to go ahead and do 3 plus 2 is 5. 3 minus 1 is 2, so 2 over 10, so 1/5. Let's repeat that process. You can see the 2 is not going to keep changing. 4, so 4 plus 2 is 6. 4 minus 1 is 3. 18, so 1/9. All right, so we have some information there. Let's try again. -1. -1, so I'm looking here, right? -1 plus 2 is 1, and -1 minus 1 is -2. So -2 is -1. All right, repeat. -3, put a -3 in this spot. -3 plus 2 is -1, and -3 in this spot gives me -4. So that's a 4, and that's a 1/2. Interesting, I see that up there. I don't know if that means anything to me at the moment or not, but I kind of like it. All right, let's put a -4 in there. -4 here becomes -2. -4 here becomes -5. That's a -10. That's a -1/5. Oh, no, +1/5. Sorry about that. So positive and positive. And oh, look at this again. All right, I'm starting to feel like there might be something going on here. Let's do one more. And let's see if what we've put in gives us enough information. Let's put the -5 in. So -5 plus 2 is -3. -5 minus 1 is -6. That's an 18. And that's a 1/9. And once again, I'm starting to see, I don't know if I'd call it symmetry, but I'm seeing some patterns here. So let's graph what we have and see if it's enough information. 2 and 1/2 looks like it's here. 3 and 1/5 is probably going to be something like this. It's hard to graph 1/5. It's even harder to graph 1/9. So all I know is that it's really, really teeny tiny. I feel like I see some sort of a trend here. Oh, sorry, I feel like I see a trend. I probably have a feeling that this probably goes up. Could I, if I had the time or desire, put in something like a 3/2 or a 1.5? Absolutely. But I have a feeling for a sketch anyway, I probably have the beginnings of a sketch here. All right, I feel like that's probably the direction we're going. I'm hitting the 3 points that I made. I have asymptotes, so I know these lines are going to run along those asymptotes. So I feel like that's probably a pretty good drawing for that upper chunk. That takes care of these first 3 bits. -1, -1 is here. I don't really know what's going on there. I have a hole, so I know the graph goes through that hole, or, kind of comes up to it and comes out the other side. And I know I have something here. That's not enough information. I don't know what's going on, so I need some more info there. So for now, I'll put a question mark. Let's see what else we have. The -3, -4, -5, these pieces. Let's do this. -3 1/2. -4 1/5. And -5 and the -1/9. This looks a lot like these 3 points. And since we had some, I don't want to call it symmetry, but it kind of feels like that's the direction we're going, I have a feeling that it's completely reasonable to imagine that this comes up. Could I double check that with an additional point here, which is at -2.5? Absolutely. But with the asymptotes, with the symmetry, I have a feeling that I'm pretty good. Brings me back to that question mark in the middle. What you should see right now is we've not done any hard math work. It's just a little time consuming. But we've invested this much time. Let's just do a little bit more. All I really think we need to do is find a little more information. So let's find out what happens at 1/2. Let's find out what happens at -1.5. So I'm going to add that to my chart. -1/2 and -1.5. And for that, I'm going to use a decimal just because I think it'll make it a little easier. So back to my table. Back to my substituting of numbers. And let's do the 1/2 first. So 1/2 plus 2 is 2.5. And 1/2 minus 1 is -1/2. And 2.5 times 5, what is that going to be? That's going to be probably 12.5, 12.5. -1.25. And I'm estimating here, I don't have a calculator. I'm going to say that's probably somewhere in the -1 point. Gosh, what is that? 3 or 4 or 5, something like that. I could probably do this in my calculator. Let's see. 20 and 12. This is where I should pause the video. Let's see. 2 and 1.5. I guess I'll just do it correctly. 2 divided by 1 point. What did I say that was? 1.25, I hope. 1.6. Let's check it. Yep, so -1.6. All right, if we're going to do it, I guess we'll do it well. And let's do the 1.5 in. So here we go. -1.5 in here, plus 2 is 0.5. -1.5 here is -2.5, and we actually just did this one. That's kind of funny. We had -1.25, so we calculated -1.6. So -1.6, that's kind of weird. That gives me what looks like symmetry. Once again, I don't know that I want to call it symmetry. Maybe we just have some good luck. So let's graph those two things. -1.6 and -1.6 is probably about here. And probably, if I erase some of these marks here, probably about here. And what I think I recognize with this asymptote is that it's going to come up. This is going to probably come up and hit the hole. Probably we're going to kind of peek over at some point. Surely if I wanted to, I could calculate some additional number, let's say at -1/2. But for our purposes now, I think we're going to skip that. And this is a pretty funky looking graph that we've created using a simplified function, a chart with holes, asymptotes, and intercepts, and then, as has been mentioned in class many times, a pretty rigorous table of values, but one that wasn't just done randomly, one that was done purposefully to try to maximize the efficiency of graphing something like this. All told, it's probably a 5 or 10 minute process. It does get faster as you try it more. So today you should probably try a few of these to get comfortable.